Welcome tonight on behalf of the Greater Sudbury Watershed Alliance. We're here to advocate and tonight educate and to also do action. Our mandate is to look after the quality of water in our lakes. Sudbury is the city of lakes, as you all know, and we're trying to preserve the quality of those lakes. And so tonight we're going to talk about septic tanks and septic beds, and we've got our contractors over here, and I would like to thank the contractors for coming tonight. We have Septic Solutions, we have Pat Taylor Contracting, we have Boris Nadev from Rainbow Cement, and we also have Herbie's. So I'd like to thank them very much for coming tonight, and again you can talk with them afterwards as well. We've got a full house tonight, so I've just taken off my jacket because it's going to get very warm here. I suggest that you do the same. Unfortunately, we can't really open the doors because of legislation and rules and regulations. But this is the Legion and the bar is open, so if you need a drink to cool off, there it is. At this time, I would like to introduce the board, and in particular the Drinking Water Protection Committee that's headed up by Linda Heron. If you can stand. Oh, there you are. And she's the chair, and she's the lady who is really responsible for all of this here tonight. With her is Richard Witham. If you could just stand again. Margaret, Lily, David, Leslie, John, and myself. So people can just stand, and they're the ones with the little ribbons on their chests there. So they're the committee, and if you want to go and say thank you to them, please do so. Tonight we're very pleased to introduce our three guest speakers. We've got Brittany Pellerin, who graduated from Sudbury's own Cambrian College with an advanced diploma in chemical engineering, technology, lab and process control. She's employed by Experience Services here in Sudbury, working as a lab technician in the material testing division. A large part of her time, though, is spent dealing with septic clients and contractors and looking to have percolation tests completed. Brittany has also completed the Ontario Wastewater Centre course on site sewage systems in 2012. She's a septic installer, inspector, and licenser. Ed Wisbicki graduated from Ryerson in '74. Began working for the Sudbury District Health Unit as a public health inspector and coordinator. His responsibilities included many public health programs, and in particular private sewage disposal. So after retiring in 2007, Ed has established his own business, Sewage Systems by Design, designing private sewage systems as an official building code designer under the Ontario Building Code. So let's welcome Brittany and Ed.
Good evening, everyone. So as it was stated, so my name is Brittany Pellerin. I'm a laboratory technician with EXP Services here in Sudbury. And again, this is Ed, and he will be helping me this evening answer some of your questions. So Ed is the experience with the actual on-site, whereas I've got more of the theory. Okay, so I was asked here to speak about on-site sewage systems, how they operate, and the maintenance required for maintaining these on-site sewage systems. Okay, so now before we get started, I'd just like to state that the material that I will be sharing with you this evening, it was taken directly from the building code, as well as material that I received during my on-site preparatory course. And some of the pictures that are part of my slideshow today have been sent to me by Dr. Basim Abbasi from the University of Guelph, and Dr. Chris Kinsley, also from the University of Guelph, and he's with the Ontario Rural Wastewater Centre. Okay, so what is an on-site sewage system? So an on-site sewage system is a system that treats the wastewater that comes from our homes, our cottages, etc. So wastewater is anything that comes from your toilets, your sinks, your showers, any water using appliance, okay? So wastewater, it contains bacteria, viruses, and it also contains solids. So it needs to be treated before it's released back into the environment and eventually back into our water cycle. So a properly functioning sewage system uses natural processes to treat these contaminants in our wastewater so that they won't harm us or our environment. Excuse me. Now, most systems have three components in common. So they'll have some type of tank, a distribution system, and a filtering bed. So what makes each system different is the actual components in the, excuse me, having some issues here with, oh, okay, who is the technical person? Yeah, boy. Sorry. Oh, I'm having some issues here with that. Sorry. How do I do this again?
Just your arms.
Oh, you know, this portion. How do I know that?
Take your cursor. Where's your cursor?
I don't know. Sorry about this.
That's the second. There it is. Okay.
Oh, okay.
So, there you are.
Perfect.
And then just bring it. Yeah, so that's it right there.
Okay, perfect. Oh, no, it's still not, it's supposed to scroll. It wasn't more hard to scroll. Oh, there we go. I don't know. Sorry about that. Okay, so as I was saying, now most systems have three components in common. They have some type of tank, a distribution system, and of course the bed. So what makes each system different is dependent on the site conditions and what is allowed by the Ontario Building Code. So the Building Code divides on-site sewage systems into 5 classes. So class 1s are privies. So any kind of outhouse, composting toilet, portable toilet, anything like that. A class 2 is a gray water system, so any system that does not collect any human body waste. Class 3 systems are for cesspools. Cesspools are used in conjunction with a class 1, and they will accept any waste from that outhouse, okay? Class 4 is a leaching bed system. These are the most common types of systems and what I will mostly be speaking about this evening. Class 5 systems are for holding tanks, okay? So the way I've set up my presentation this evening is I'll be speaking about some of the classes that might not be as relevant or as important, and then I'll be concluding with Class 4, and then following that, the general operation, maintenance, and potential malfunctions that could arise, as well as clearance distances that are important. So a Class 2 system, as I've mentioned, Class 2 systems are for gray water treatment. So the treatment and the disposal of gray water. So any wastewater that does not contain any human body waste. So any water that's derived from your plumbing fixtures. So washing machines, wash basins, your bathtub, your sink, things like that. So the system is adequate for the disposal of gray water, and only when the daily amount of gray water is small and the site conditions will allow for it. So that's something that the building code would tell you if you can have a gray water system or not. Class 3 systems. So Class 3 systems, as I've mentioned, can only be used in conjunction with a Class 1 system. So the use of a Class 3 system, it's usually discouraged though because the human body waste will quickly clog up the soil particles, which will slow down the actual operation of the cesspool. So for this reason, Class 3 systems usually have very short lifespans, and they're not recommended unless all other possibilities have been completely rejected. So as you can see on the picture, it's a little smaller than I would have liked, but you can kind of see how it's, you've got your cinder blocks on each side, you've got your inlet pipe, and that inlet pipe would be connected to where your privy or any kind of your outhouse would be. So Class 5 systems. Class 5 systems consist of a holding tank. And that holding tank, it's designed and positioned to accept sanitary sewage until the capacity of that tank is reached. So accumulated sanitary sewage in the holding tank is pumped out and hauled away by a licensed waste haulage operator, and it's done on a regular basis or when the tank is full. So the building code does describe 4 acceptable conditions where a holding tank may be used. And in any of those 4 conditions, a written agreement must also exist between the property owner and the waste haulage operator. And that agreement states that there's a regular removal of accumulated sanitary sewage from the tank. So you always want that to be emptied out. Okay, so Class 1 systems, as I've said, Class 1 systems are used for the disposal of human body waste. So the building code defines Class 1 systems as chemical toilets, incinerating toilets, recirculating toilets, self-portable or self-contained portable toilets, and all forms of privy. So a privy is an outhouse, okay? So any forms of privies, including portable privies, earth pit privies, which is actually the one that's on the screen there, a pail privy vault, and composting toilet systems. So these systems must not receive any gray water or any other waste water from plumbing fixtures such as like your kitchen sink or your bathtub. So it shouldn't receive anything like that. And oh, geez, sorry, I'm having issues with this cursor again. So typically the system is used in remote areas such as seasonal cottages or parks, and or they can be used actually on construction sites for temporary purposes. So Class 1 systems can actually severely limit your plumbing options. So, sorry. Terrible technical difficulties. There we go. Sorry, so yes, they can severely limit your plumbing options. And if a gray water system is needed, then a class 4 would actually be recommended instead of having a privy and a gray water system. It would just be easier to have a Class 4 system. So the building code does state that Class 1 systems do not require the use of a building permit, but I also want to note that although you don't need a building permit, the building code does stipulate clearance distances and construction regulations that you must follow. Okay, so I'm just going to go over some of the privies that I've named. So the first one that's on the screen, the earth pit privy, it's only suitable where there's a sufficient thickness of soil above either the bedrock or above your high groundwater table. Okay, next one, so the image at the top left hand of the screen, that's a vault privy, and it's suitable where there's not adequate soil available to dig an earth pit privy. So you can, it's kind of small, but in the image there's actually, it's vaulted up over a tank, and that tank actually has a hatch that can be, the effluent can be removed from there. Okay, so the next one is a portable privy, and that portable privy is the bottom image right there. Portable privy combines in one superstructure the receptacle for the human body waste and the actual containment itself. So it's really important to get that structural rigidity for this type of privy. Alright, so Class 4 systems. Class 4, like I said, the most common type of on-site sewage system. It accepts gray water as well as that human body waste. So this class is generally made up of 3 different components. You have your tank, your distribution system, as well as a bed. So as sewage leaves your home or cottage, its first stop is your septic tank. Okay, so at this point your sanitary sewage is still filled with that bacteria, the contaminants, and the solids. So your septic tank allows for that separation and the filtration of those solids. So your raw sewage now leaves the tank as partially treated effluent. And what it does now is it goes through that baffle and it enters your distribution system. So the distribution system ensures that your bed receives effluent in even portions as well as even areas. So you want that proper distribution. I mean, no homeowner wants to come home and see big pooling in the back of their yard where their distribution lines are. So that just would not be good. You know, you don't want pooling in your backyard. Okay, so as the effluent exits the distribution pipes into your bed, it percolates through that soil, where it eventually goes through the final stage of treatment and will eventually re-enter that groundwater table. So like I said, class 4 systems are the most common, so I'll be taking the rest of my time to go through the inner workings of the system, the operation and maintenance required, as well as some malfunctions. So septic tank, it's a watertight vault with at least 2 compartments. The slide ahead shows three different materials that a septic tank could be made out of. So we've got concrete, fiberglass, and polyethylene. So your tank, it's been sized, it's been located, and it's been constructed in accordance with the building code. So the building code does state design standards for sewage systems. Just to list a few standards that may be relevant, all access openings must be located to facilitate the pumping of all of your compartments, okay? A tank must not be covered by soil or leaching bed fill to a depth greater than the maximum depth of backfill that the tank is designed to withstand. Every septic tank must also be constructed in such a manner that the sanitary sewage will flow through those 2 compartments. So here we have a cross section of a septic tank. So the main purpose of your septic tank is to collect that sanitary sewage and to separate the solid material from the liquid. So as that raw sanitary sewage enters the septic tank through the baffle, so you can see the baffle on the left-hand side. So as your effluent is entering through the tank, the heavier solid materials will begin to settle to the bottom, and that will eventually form a sludge. So you can actually see that sludge layer. So those are all your solids. They're settling down, and they're forming that sludge. Whereas the top portion, your scum, that's made up of all of your greases, your lighter oil, so anything like that is going to rise to the top and it's going to settle to form that scum layer. So for the most part, tanks are designed to retain sewage for 48 hours. So this time allows for settling of those solids, and it also allows for that treatment process to really begin, because you want that effluent to have some treatment before it makes its way to your bed. So the good bacteria in the septic tank will begin to decompose, and it will liquefy some of the solid matter that's retained within your tank. So once displaced, that partially treated effluent will leave the tank through an effluent filter. Now, unfortunately, in this picture, you can't see an effluent filter, but it would be at the exiting baffle. The next slide, you can actually see where the filter is. So effluent filters or screens, they've been around for a number of years. They're commonly used, and as you can see on the slide, since January 1st, 2007, they have become mandatory for new tanks. Now, if it's possible, if you have an older tank and your tank can be retrofitted to have an effluent filter, I would definitely recommend it. So what the effluent filter does is that it protects against the discharge of your larger suspended solids, and it reduces the overall concentration of the total suspended solids within your effluent. It also helps to promote the treatment of your effluent. Okay, so another way that we can take care of our septic tank is by having it pumped out. The frequency of your pump outs depends on a number of factors, such as the size of your system and the volume of waste that's entering the system. So a general recommendation for septic tank pump outs is actually every 3 to 5 years. So because solid sludge builds up in the tank, it'll start to take up some room. So although that good bacteria is eating away and decomposing and liquefying some of that sludge, it can't keep up with us. I mean, it's only a bit of bacteria. We're human. We're constantly using whether it's wastewater, going to the bathroom, using our sinks, we're filling that up constantly. So it really can't keep up. So one of the ways that, excuse me, one of the ways that you can actually check the level of sludge within your tank is using a tool called the sludge judge. So the sludge judge is a lot. It is called the sludge judge, I know. So the sludge judge is something that you would put at the first compartment of your tank, and when you push it into your system, you pull it back out again, whether it displaces or it's got notches on it, it will tell you how much sludge you have at the bottom of your tank. So if you know the size of your tank and you've realized, okay, I'm getting close to that 1/3 part, it's time to call and have that tank emptied out. Okay, so before we move on to the next component of the sewage system, I just want to touch on treatment units. So they're used with certain leaching beds, and generally when the clearance distances or percolation rates won't work for a certain property. So the inner workings of these tanks operate on the basis of aerobic digestion, meaning that the effluent is treated using bacteria and oxygen. So regular septic tanks, they operate on the process of anaerobic digestion. So they're just using the bacteria. There's no oxygen in there. It's filled with gases and all this kind of stuff. So your treatment units, they're using aerobic. They're using that bacteria and the oxygen. So what that means is that by the time that effluent leaves your tank, it's far less contaminated. And if you look at the picture on the bottom, you can actually see the different levels. So I've penciled in what the effluent quality would be like for a general septic tank. So you can see it's sending out effluent that has 150 on average suspended solids and CBOD5s. So if you look at that compared to what a treatment unit is pumping out, the levels are astonishing. So for a treatment unit, you don't need as much room as you would have with a general septic tank. All right, so now that we've covered the inner workings of your septic tank and we've learned a little bit about how your sanitary sewage becomes partially treated effluent, we can continue through the process, which brings us to our distribution system. So as stated previously, the purpose of the distribution system is to evenly distribute the effluent throughout your leaching bed area. So components of this part of system may include the piping that connects the septic tank to either a distribution box or a header, and from the distribution system to each of the individual distribution pipes. It could also include a pumping system to dose the leaching bed. So that's only dependent on if that type of system that you have has a pump to it. So a pump could be used for either pumping your effluent from a distance, if you've got really long distribution pipe, if you have to pump uphill, or if you're dosing your bed. So certain systems will dose their bed. So other components could be distribution boxes or header to split the flow to segments of the leaching bed, or directly to each line of the distribution pipe. And lastly, of course, the actual lines of distribution piping are components of the distribution system. So there are three main types of distribution systems. We have gravity, we have dosed, and we have pressurized. So the gravity flow distribution system is the most common method of effluent distribution. The effluent is pushed from the tank by hydraulic displacement, and then it trickles by gravitational pull from the septic tank to the individual distribution pipes. So if you look at the image, you can see the dwelling is kind of more uphill, and then there's a bit of a slope, and that slope is helping to carry that effluent down to the tank. And again, you can see the grading. Again, there's another slope, and it brings you to your actual leaching bed. So this comes back to the basics of kind of what goes in, what goes out. So if you're flushing your toilet or something, that liquid that's making its way to your septic tank, an equal amount will also leave your septic tank, okay? So there's two main types of distribution components that are used for distributing the effluent evenly to the individual distribution trenches under gravity flow. Excuse me. So you have your distribution box and you have your distribution header. So a distribution box is made up of concrete or PVC, and it's used to distribute your effluent from an inlet pipe to several outlet pipes that have been leveled to the same elevation. Now, it's very important that they're leveled to the same elevation because any kind of shifting or settlement, frost, heaving could actually cause your pipes to they could settle or even crack. And settling or cracking will cause effluent to either overflow a certain area of your bed, or it will cause effluent to end up in a portion of your bed where it really shouldn't be at that point. Okay, so to prevent the shifting, a base of well-compacted granular material or even an engineered design slab or footing should be provided for that. So one or the other, either granular fill or that engineered slab. So as a rule of good practice, if you have more than 8 lines of distribution pipe, you should really consider using a distribution box to make sure that it gets spread out properly. So in general, a distribution box is recommended for larger systems, and it's good too because they can actually be cleaned, they can be inspected, and they can be adjusted after the bed is constructed. So that's a good thing. The distribution header. So generally it involves using T-connections and it will divide the effluent amongst a series of individual distribution pipes. So a distribution header is usually preferred for smaller systems, and again, those operate under gravity flow conditions. Next is the dose distribution system. So a dose distribution system is necessary when the total length of your pipe required is 150 meters or more. So you need a pump or a siphon, and that pump or siphon is used to send a specific volume of effluent to the leaching bed in one single dose. So it's shooting it through to make sure that it is dosed accordingly. So this periodic dosing of the leaching bed will provide a more even distribution of your effluent over the entire bed area. So compared to the gravity discharge, excuse me. So it also allows the bed to drain between the doses, which promotes a good bacterial action within your biomat. So I'll actually be covering biomats coming up soon, so don't worry if you don't know what that is. So care should also be taken to avoid freezing of the distribution pipes during the winter. Okay, so next pressurized. So a shallow buried trench system and type B dispersal bed systems use pressurized distribution systems. I will be covering both of those types of beds later on in the presentation. So in these systems, a minimal pressure is maintained at the terminal end of all of the lines of distribution pipe. So these systems are the most efficient in achieving even distribution of the effluent over the entire leaching bed area. Okay. All right, so now to our leaching bed. So leaching bed, it is the critical part of that class 4 sewage system. The performance of the leaching bed is measured by its ability to perform certain functions. So some of those functions are the treatment of the effluent within in the soil, and secondly, to absorb, or the absorption of the treated effluent by the underlying and surrounding soils without it breaking to the surface. So the leaching bed is also known as, it's got a couple names, a tile bed, a filter bed, a drain field. So they all mean the same thing. So the leaching bed is an area of gravel and soil layers where the effluent is further filtered and broken down and then absorbed. So the gravel helps to, it helps the effluent trickle down through the surrounding soil, and this is where the last bit of treatment will take place. So the picture that's up on the slide right now, where you can see there's gravel mounds over there, that's underneath that's where your distribution piping is, for those of you that have never seen that. And again, kind of at the back, you can see there's some white pipes there, so that would be your distribution piping. So that is an image of what it would look like. All right, so the biomat. So as your septic system ages, a layer forms just under that gravel trench, and that's called a biomat. So the bacteria in the biomat feeds on that organic matter that's inside your effluent, okay? So the biomat plays an important role in the treatment process. If it becomes too thick though, it can actually be problematic and it can cause it can prevent the proper drainage, okay? So once the effluent filters through that gravel and it begins to filter through the soil beneath it, the receiving soil is the most important component in the septic system. The soil filter is the last line of defense for breaking down any of that remaining bacteria, viruses, or any other contaminants that could eventually make its way back into the ground or surface water. So once the effluent passes into the soil, it's exposed to bacterial action in the soil, so in the pores and in the void. So on the picture you can see there's kind of those big chunks there, so that's just kind of showing you the pores and the voids, and you can see how your effluent would technically be trickling down, and like I said, this is where all of these reactions occur, and that good bacteria is eating away all of the contaminants that you don't want making its way back into the water. So this process must permit sufficient time for effluent to be in contact with the soil particles in order to achieve some of that treatment. Okay, so some of the bacteria that is flowing through will actually be, it could be eaten up by vegetation, so by your grass, things like that. Some may even be attached to soil particles, and then some will just continue to percolate through the soil, and it will actually dilute eventually to acceptable levels. So for the treatment in the soil to occur, the effluent must pass through unsaturated soil. Therefore, it's very important that there be a sufficient thick layer of unsaturated soil above the groundwater table. So the soil type and depth are determining factors in the proper breakdown of water contaminants in this final stage. So a leaching bed should be made up of soils that will allow wastewater to pass through slowly enough so that it allows the breakdown and the treatment, but quickly enough so that it doesn't clog the leaching bed. So touching on the soil type and distribution, so to determine the type and distribution of your soil, this is where you would take a representative sample of where your distribution piping would go, and you would bring it into a lab like EXP's, and you'd come see me, and you would bring me a sample of soil. Okay, so that soil, I would test it, and I would tell you exactly what it consists of. So the top picture, it's really small, I'm so sorry, I thought it was going to be larger, but the top picture on the left hand side, you can see, so that's more of a granular material, a coarse gravel, something like that. It's not an effective filter, so your effluent is flowing through so fast that it doesn't have time to be treated. And what that means is that you're getting that effluent that isn't good yet, you're getting that into your groundwater, you're getting it on your bedrock, it's not good. The one on the right hand side, so that's clay. So you can see how the layers are so compact, they're tight together, and that's because clay particles are extremely small. So they're so close together, so nothing can really go through. Some may percolate through, but not enough and not quickly enough. So it's not really being treated, and eventually that will cause pooling at the top of your yard, and like we said, we don't want that. We don't want effluent in our backyard. Okay, so the bottom picture is actually the report that you would get from me if you brought a sample to the lab. So the curve would tell you exactly your percolation rate, which is something that you need for your design and things like that. And then I will also tell you the soil classification. So in cases where sites have clay or gravel, an appropriate filtering bed will have to be installed using imported soils. Oh, there we go. So after filtering through the soil, the septic system effluent continues to seep down into the ground until it reaches groundwater. So you can kind of see that in the image. We've got our leaching bed. You can kind of see where the treatment zone is, and eventually it makes its way back through the groundwater and into a well. Okay, so by that point, excuse me, we want it to be properly treated and have those low levels of total suspended solids and CBOD5s. So, so because of this connection, it's very critical that we properly treat our wastewater before it's released back into the natural water system. So any malfunctions along the way can actually jeopardize the quality of surrounding water. So if the input of effluent into the soil exceeds its capacity to receive and transmit the effluent, mushy ground, and that surface breakout will happen. So this is a common cause of failure in sewage systems, especially in larger systems where the problem increases in proportion to the increasing daily sanitary sewage flow. So therefore it's very important to follow your regulations about sanitary sewage flow. You want to follow those percolation times and clearance distances. So I will be covering clearance distances later on in the presentation. So when the percolating effluent reaches the level of the water table or the bedrock or the impermeable soil, the sanitary sewage will mound on top of this level. So you can actually see mounding on the left-hand side, and so the mounding will continue until that sufficient pressure is reached to force a downward or lateral movement. So the greater the resistance of the underlying soil to this movement, the greater the portion of the liquid that will move laterally, forming a plume. So a plume is a column or an area where one fluid will actually flow through another fluid. So in addition to the greater the resistance to movement, the higher the sanitary sewage will mound to the surface. If it mounds to a level that will flood the soil sewage interface, it will remove the oxygen from the soil and it will prevent that treatment to occur. So in extreme cases, it will cause a backup of sanitary sewage, and it could result in a surface breakout of that effluent. So the capacity of the leaching bed to safely receive and transmit the applied effluent without mounding or breakout is one of those major factors in design. Okay, so this leads us to actually the different types of leaching bed designs. So, conventional in-ground leaching bed. These are probably the majority of the systems that many of you probably have. They're very most common type of system. So it's the system is set up with absorption trenches and distribution pipes set in a layer of stone within the native soil into which the effluent from the septic tank will be distributed. So conventional in-ground leaching beds are normally installed where there's where the high groundwater table or the bedrock is more than 90 centimeters below the bottom of the trenches, and the percolation rate of the soil will be between 1 and 50 minutes per centimeter. And as I've said previously, that percolation rate, you'd get that from bringing a sample to me, and it would be on the report that you would get. So the filter bed system, it's an alternative type of leaching bed, and it may be used on site where there's either insufficient area for a conventional bed or where there's natural features that are impeding you. So things like trees and stuff like that could minimize the available area for your leaching bed. So a filter bed allows the sanitary sewage to enter a series of distribution pipes. And all those pipes are set in a common layer of stone. So the building code actually specifies the grain size requirements for filter sand. And again, that's something that I would test. So certain contractors or installers may have filter sand that you can actually purchase, and they would bring that to you for the installation purposes. So, excuse me, the stone layer covers the surface of the filter sand overlying the native soil. So filter beds can be installed, they can be installed in ground, they can be installed partially raised, partially excavated, or even fully raised. So an in-ground filter bed can be installed when the T-time of the soil it does not exceed 15 minutes per centimeter, and that there's sufficient depth to satisfy the vertical separation requirement. So if there isn't enough soil depth, or if the T-time exceeds 15 minutes, then you have no choice but to do a fully raised bed, okay? So a raised leaching bed, it's constructed above ground where one of the following situations would apply. So the high groundwater table or bedrock is less than that 90 centimeters of clearance to the bottom of those trenches, or that the T-time of the soil is less than 1 minute per centimeter or greater than 50 minutes per centimeter. So in these situations, leaching bed fill is imported to provide that additional or higher quality material for the absorption of the effluent. So leaching bed fill is typically placed on top of native soil. Okay, so during construction, that organic soil beneath the leaching bed is removed, and excuse me, and the other underlying soil will be roughened to permit a good interface between the overlying leaching bed fill. So the sides of the raised bed, they're sloped to prevent that erosion and to allow for easy maintenance or grass of the grass cover. So a shallow buried trench system. So I mentioned this earlier when I spoke about pressurized distribution systems. Okay, so like I said, shallow buried trench, it's a pressurized distribution system, and it has the following characteristics. So it's designed to receive an effluent from a level 4 treatment unit. Okay, so the effluent being discharged to the trench is time dosed, and the percolation time of the soil receiving the pre-treated effluent is between 1 and 125 minutes per centimeter. So a shallow buried trench leaching bed is the only type of system that can be installed in soil with a percolation time that exceeds that 50 minutes per centimeters, okay, and that can go all the way up to the 125 minutes per centimeter. An important design feature of the system is that the pressure distribution pipes drain after each time dose, so there's minimal chance of freezing. The system also requires very small area compared to your conventional system, and that's because of that treatment unit. So it's allowing for the effluent to be that much more treated before it makes its way to your bed. So that's why that area doesn't have to be as large. Okay. So our last two types of beds are type A dispersal beds and type B dispersal bed. So a type A dispersal bed on the left hand side, it's a leaching bed that receives effluent from a level 4 treatment unit. The bed is comprised of a stone layer above an unsaturated sand layer. So a treatment unit that is used in conjunction with a type A dispersal bed must be designed such that the effluent does not exceed the maximum concentration of 10 milligrams per liter for both suspended solids as well as CBODs. And that actually, that is the same for type B dispersal beds. It must not exceed those acceptable levels. So a type B dispersal bed, it offers additional design flexibilities by allowing another option for a leaching bed for highly treated effluent. So this is a solid absorption system used in conjunction again with a level 4 treatment unit, and it's a pressurized distribution system, and it utilizes even distribution. So that pressurized distribution system, it ensures that all the lines are getting pumped evenly. Okay, so the pressure distribution is important since that highly treated effluent will lead to a weakly developed biomat. Okay, so there isn't enough of that bacteria to promote for that good bacteria to build that biomat. Okay, so the building code does define a type B dispersal bed as a leaching bed comprised of a pressurized distribution system that uniformly distributes effluent from the level 4 to the underlying soil through a set of distribution pipes inside a bed of septic stones. Alright, so clearance distances. I said I would cover this, so what I've done is I've got 3 slides with clearance distances on them. So I'm happy that these ones are quite large, that hopefully everybody can see it. So this first one covers the minimum horizontal distances for classes 1 through 3. Okay, so while you guys kind of take a look at that, I don't know if some of you may want to write some of this down or whatnot. This can all be found in the building code, okay? So although the building code does stipulate those acceptable minimum clearance distances, there are situations where greater distances are required to provide kind of that safety margin to protect the environment or adjacent properties. So you don't want to be affecting your neighbors also, so that would just not be good. So what as I said, I've made the 3 slides here, and while you kind of take a look at those slides, I'm going to touch on the things that aren't in those tables. Okay, so the minimum clearance to a water source, for instance, that won't be on your table, but that is something that's extremely important. So the building code states that if a tea time is less than 10 minutes per centimeter, the greater clearance distances are required unless you can prove that it is unnecessary. So for example, if your leaching bed is going to be installed near the shoreline of a sensitive lake, and the soil, which is over bedrock, consists of coarse sand with a tea time of 3. So for those of you that don't really understand tea time of 3, that's very quick. That's like coarse beach sand, almost like it's like a mixture of sand gravel. So that's quick. You know, that's very quick. They're large particle sizes. Okay, so it's expected that the leaching bed should be located further away from the lake than that minimum 15-meter clearance distance. Okay, so in addition to such matters of good practice, it's also important to be aware of any restrictions with the region or jurisdiction, or anything such as bylaws or official plans, or even with the conservation authority. So that's very important. So our next slide of clearance distances shows the minimum clearance distances for a class 4 and 5 system. So your class 4 again is your leaching bed, and 5 is holding tanks. So while you take a look at that, I'm going to discuss minimum clearance distances for raised leaching beds. Okay, so for a raised leaching bed, the 5-meter clearance distance must be increased to twice the height that the leaching bed is raised above the ground between the bed and your structure or your home or whatnot. In the case again of a raised leaching bed, the distance must be increased again by twice the height that the leaching bed is raised above the ground between the bed and the property line. And the location and construction of a raised leaching bed should not cause any problems to neighboring properties. And again, if you're following the code, that shouldn't be a problem. So this is our last slide on clearance distances, and this just has the minimum horizontal clearance distances. Okay, so the building code doesn't regulate clearance distances of leaching beds from trees on the property, but there are some good rules of practice that we really should follow. So you want to ensure that your leaching bed is free of trees and bushes, so that the area is well aerated and sunlight can reach the surface. So you want that sun to hit your leaching bed. It's helping to dry it out. You know, you never want to oversaturate your bed. It's recommended that trees be at least 3 meters from the leaching bed, and this is because tree roots, they'll go anywhere where there's liquid or nutrients. Those roots will find it, and anything like that. If you have roots that are making their way into your distribution system, so your distribution pipes or anything like that, that could cause a lot of damage. Tree roots will actually make their way inside your distribution pipe and will continue to grow. And what will happen is that it will cause your pipes to crack, and then that just leads to sewage seeping out again where it shouldn't, and that's just something we don't want. So another thing to consider with trees is that, so trees with rapid growth, trees that have high water consumption, and root proliferation, so any kind of willow, silver maple, poplar, you should never have any kinds of those trees located near your leaching bed. Alright, so we've reached our operation and maintenance portion of the presentation. The building code has certain requirements within which a sewage system must operate and be maintained. So Some of you might wonder, well, whose job is it to maintain and operate? That is your responsibility. It's your responsibility to take care of it. It's your responsibility to ensure that things that shouldn't be going down there aren't going down there. So your system is your responsibility. Any requirements, those can be found in the building code in section 8.9 for any of those of you that have access to the building code. So section 8.9 will tell you any of the system requirements or how to operate and maintain your system. So these operation and maintenance requirements apply to all types of sewage systems, new and previously existing. So general requirements that apply to all systems requires that sewage systems be operated and maintained such that sanitary sewage or effluent must not seep, it must not discharge or otherwise escape to the surface of the ground from a sewage system. So I've already mentioned this already. We don't want that groundwater to break through. So should this happen, your system is considered unsafe and it must be repaired or replaced immediately. Okay, so sewage or effluent must escape only from an outlet or part of a sewage system specifically designed for that purpose. So just an example, if you have if the ground surface of a leaching bed becomes wet with sanitary sewage, then you know that the system is malfunctioning, and then that's actually a health hazard. So that's not good. Okay, another point is that the sewage or effluent must not seep, must not discharge or otherwise escape from a sewage system into a piped water supply, water course, or groundwater, or even surface water. You don't want your effluent making its way into any kind of well or something like that. If you don't want to be drinking that effluent, that's not good. You want it to go through the proper stages of treatment so that it becomes safe again. Another point, so septic tanks and other treatment units that form part of a class 4 leaching bed system must be cleaned whenever the sludge and scum occupy 1/3 of the working capacity of the tank. So that's actually something that I've already mentioned this evening. So just a reminder, once it reaches 1/3 or even before that, you have that tank pumped out. So a licensed sanitary sewage hauler must remove that sanitary sewage for you. If you're planning on looking in your tank, just a quick note, make sure you're wearing the proper protective equipment. You want to wear gloves, be careful of gases, things like that. Some of that stuff is very dangerous, so you want to make sure that you're wearing the proper equipment if you're looking within your tank, and you want to be safe about stuff like that because it can be dangerous, okay? Last point, so every sewage system must be serviced and maintained regularly so that all components of the sewage system function as they are intended. So construction must remain in accordance with the original permit documentation and the manufacturer's requirements. So you can't just make changes to your system. It has to follow what the health unit would have approved for you, okay? So the code also requires that the land in the vicinity of the sewage system be maintained in a condition that will not cause damage to or impair the functioning of the sewage system. So I also would like to add that the building code does state a few more operation and maintenance guidelines, but I just picked the ones that I felt were more important for this evening. Okay, so malfunctions of an on-site sewage system represent a public health risk and can cause environmental problems. In addition, it can depreciate your property value and actually make that resale, it can make it difficult. So a malfunctioning system should never be ignored, as the problem, it won't correct itself, it will actually probably get worse. Okay, so that's not good. It should be noted that any system that contravenes the building code is considered to be unsafe. So one of the greatest challenges of a malfunctioning system is actually to determine the cause of the problem. So a malfunctioning system has symptoms. So it tells us when it's sick, when there's something wrong with it. So those 4 symptoms are a foul odor, a sanitary sewage backup, a sanitary sewage breakout, or groundwater contamination. And each of these systems can be caused by various problems. So identification of the actual cause of the systems is the first step in finding the right solution for your problem. Foul odors that are generated by on-site sewage systems may be indicative of any one of several problems. The first step is to find where that odor is coming from. So if the odor comes from the leaching bed, examine the surface of the bed for effluent breakout. The presence of the effluent on the ground surface may be the source of the odor, but it could also indicate a more serious problem with the entire system. Another thing would be that if gas, so generated by anaerobic decomposition of sanitary sewage in the tank, so if you have a treatment unit, this isn't something you got to worry about, but most of us that have that regular septic tank, this is something that we would look out for. So that could be the cause of the foul odor. So gases are usually vented through the plumbing stack of the home or cottage where the sanitary sewage originates. And then it's dissipated into the air. So if the plumbing vents are not properly constructed, then a foul odor may be noticed outside your home or your cottage. So if the cover of the septic tank isn't properly sealed or covered, then the gases generated could actually leak out of there, causing a foul odor as well. If a foul odor is noticeable inside your home, try to determine where the odor is the strongest. An odor coming from a floor drain or a wash basin or a bathtub indicates an improperly installed plumbing trap. So the plumbing, to prevent those gases from entering through your house. So a plumber would actually call a plumber in and they could install one for you or repair the one that's been damaged or broken or whatever. Another issue with odor is that an electrical conduit that connects the pump chamber to the building or your home or cottage could also be a pathway for gases. So if it's not properly sealed during the installation, there's a potential for that sanitary sewage, those sewage gases actually to enter. So if gases are entering through that electrical conduit, call an electrician, have them come in and repair that point of entry for you, okay? So lastly, if a sewage odor is coming from the weeping tile around the footing or foundation from the sump pit, you must locate the source of that odor. So the problem is usually caused by settlement or frost, heaving, things like that from the septic tank. And that'll result in a breakage of the pipe along the building and between the building and the tank. So in this case, the outlet pipe should be excavated and then repaired. So sewage backup, sanitary sewage backup into a building occurs when the sewage system is unable to accept wastewater generated from your home or cottage. So the sanitary sewage then flows from the plumbing back into the building. This backup may overflow inside the building, typically at one of the lower plumbing fixtures, so a floor drain, a downstairs bathroom, things like that. A backup can be caused by a simple blockage in the external sanitary sewage pipes in the tank or the distribution. If this is the case, the solution to the problem is fairly simple. Locate and remove the blockage. However, sanitary sewage backup in a building may indicate a more serious problem. So the leaching bed may be full of effluent and unable to accept any more wastewater. Okay, so if the level of sanitary sewage within the tank is below the level of your inlet pipe, so your inlet pipe is where the sanitary sewage is coming in, if there's a blockage between the building and the inlet tank, so a plumbing contractor can actually, that would be the person to call to have this type of blockage removed. If the level of sanitary sewage in the tank is above the inlet pipe, the blockage is on the outside of the tank, so perhaps in the distribution system or somewhere in there, so that would be like the header or the distribution box, things like that. A high level of sanitary sewage within the tank could also indicate that the entire leaching bed is saturated and the receiving capacity of the ground has been exceeded. So there's too much. Okay, so the sanitary sewage must be pumped from the tank to determine whether there's a rise in sanitary sewage level and if it's due to bed sanitary or bed saturation or if it's due to a blockage. Sewage breakout. So another problem, I've mentioned it a few times this evening, is sewage breakout, so on top or near the leaching bed. This ground can become wet and spongy, and a pool of wastewater may form. Okay, so if there's a sewage breakout, it's important to find where it is, and that can be found by excavating in certain different areas and seeing if there's a crack or if there was some displacement due to frost or heaving or even ground settlement. So ground settlement can cause your pipes to kind of lower again, and this comes to where we want our distribution pipes to be leveled. So if there's that settlement and it's got a greater slope, well, more of that effluent is going to be making its way down the pipe that's got the greater slope. So you're going to be oversaturating that specific area of your bed, and that's how that would cause that sewage breakout. Lastly, oh, that's it. Oh, do you want me to just
Wrap up.
Yeah, okay. So last one, groundwater contamination. I was hoping to talk about this one a bit more because it does involve our lakes and waters here. Unfortunately, I don't have much time left, but it's very dangerous. If there's any problems like that, it's very costly to repair. But if there is an issue, that's something that you want to get on right away, because by the time you've caught the issue, it's already impacted your lakes or wells, and that's not good for the environment. So that's something that you want to make sure doesn't happen. Again, groundwater contamination. Okay, so proper care of your septic system is essential. Even new systems can malfunction. So again, it's your responsibility to take care of your system, even after the initial installation and all that. So just a quick note, we often don't realize that we can damage our bed area, but things like driving even a quad or a snowmobile over your distribution pipe can actually compact the ground enough to cause that settlement or even break some of your piping. So it's important to not drive over where your leaching bed area is. It's a very sensitive part of your system, the most important part, and you want to take care of it. Okay, so again, sorry I'm running out of time, but thank you so much for having listened. I really appreciate all of your time, and if you have any questions, my contact information is up on the screen. If maybe I don't answer your question today or something and you feel like sending me an email or giving me a phone call, that's more than all right. I can help answer your questions as best as I can. Ed can also answer your questions also.
Okay, thanks.
As you can see, she covered just about everything you'd ever want to know about private sewage. Now you're looking at an old-timer. I've been in this industry for 44 years. There are people that probably might have seen me over the years. I've inspected several beds. Probably people here have inspected their beds. So, right from 1974 when it went to the Ministry of Environment, right into 98 when it went into the Ontario Building Code, and 98 is when they fine-tuned everything. And they specifically detailed everything you would have to do to put in a proper system. And as a designer today, I have to follow all those rules. So I guess I'm going to be all over the map a little bit, but if your bed is prior to 98, there'll be some things missing that would have been put in after 98. A bed that's used on a regular basis, according to my engineer's book, is plugged after 25 years. So if you got an old house and the bed's 40 years old, don't think it's the greatest thing in the world, because and you know, if you're not using much water, it might be working a little bit, but if you're using it the way people want to, it's not going to work. I've inspected hundreds of faulty beds over my time, so I'm almost like the sewage hound dog, if you think about it, until 2007 when I retired, and then I thought it'd be great if I could design. So my goal in design is to make sure when I'm finished designing it's going to work. So it's highly detailed. A lot of things about designing, it's not rocket scientist stuff, high and dry. What do I get from people? I want to have it down here because it comes out of my house at this level. Well, it's going to come out of here and you want gravity, you're in the water table. These are the things that happened a long time ago. So people are shocked today when they consult with me and I explain the proper systems for their properties. Not. So as a designer, people are calling me and asking what, and then I go to properties. I have several systems I can design for people. Small lots, huge lots, we have options. But the big thing about sewage systems that I can add, just only personal experiences, the Class 2 system, the leaching bed, is for very limited use, like a hunt camp. And you would have to hope you have good soil, because the building code really doesn't, it gives you a challenge in clay. I really can't design Class 2 leaching beds in clay, because the excavation is usually the footprint of a small excavation for a basement, because it's all about the side walls on the clay and how much water goes through the clay. And so when you plug in this building code formula, you need a huge area. So often when I'm approached, we have to think about maybe going to a full system. You know, maybe you only want a leaching bed, you want that, but after that you're going, the size of that leaching pit is going to be almost as big as a filter bed system. These are things that people don't understand. Clearances from lakes, Fairbanks is 100 feet. So your septic systems have to be 100 feet back. Anywhere else around here, as far as I remember, it's 50 feet for septic systems from surface lake water. The Spanish, the whole area of Spanish Saulville River, the council decided that everybody had to be 100 feet away. So these are things you have to know, and I had to know as a designer, so I got my eyes open when I was designing in the Spanish area. Everything had to be 100 feet away. And another huge restriction is the floodplain. You cannot put your system in a floodplain. And I've had some complications with that, where I've designed the bed in an old subdivision. Everybody around has a septic system. The health unit turned this guy down because he had to be 12 feet high. He had to be in the sky with his bed, because the river did overflow the banks in the spring. And then I tried to explain that a tile bed can take a saturation once and twice. It can do that, but the Conservation Authority is adamant you cannot put a septic system in the floodplain. So you have to think about that one if you're buying property. Now, maintenance on your education is not provided as much as far as I'm concerned. Your sewage system is designed, and a lot of times it's minimal. People put minimal, they say they're not going to spend any money, they're going to just put this much in. And what's happening then is it's just saying that, you know, 6 people using it moderately during the day, it might work, but it doesn't really compensate for a half-an-hour shower. And it's happening. I mean, for some crazy reason, people are showering long. And if you have a filter bed and you're doing 5 loads of laundry in one day, you're blowing it. You're oversaturating it. So you almost have to take your laundry 5 loads on 5 different days. These are little things that you have to know, because water saturates the ground quite readily. And it's a joke, I always say city slickers go to the country and they start using the water like they do downtown, even though they're supposed to be reserving it everywhere. And they usually, sometimes they'll blow out their filter beds. And the other thing is that cottages, what happens on the weekend, we have parties. We like to bring our families and we're socializing. I highly recommend a backup outhouse for that reason, because you will blow out that bed on that weekend. Now, some huge designs that I do, I have to put in balancing tanks for like if it's a motel that's busy on a weekend, then I have to put a huge design a big balancing tank that'll distribute the weekend's usage for the next 5 days. That eliminates a much large sewage system that would be required. These are little things as a designer. The laundry waste and grease is what plugs your soil. And your normal washer is acceptable according to the engineer book. And what's really unique today is they've added the filter on the tank, and that will eliminate some of the lint, and it will kind of collect some of the grease. But a lot of the tanks don't have these filters today. So if you're refurbishing or pumping out your tank, you may want to look at getting that effluent filter installed. I installed one at my cottage several years ago when they first became mandatory. Now, here's the thing as a designer in Sudbury. I don't have it easy because all my lots are rock and clay. And water does not move well in rock and clay. So my design is clearly modeling clay, covering rock with clay and modeling the clay, and trying to make the water flow gently without channeling and polluting what's down below. So my drawings are very detailed in clay, and the odd time I get sand, and then I'm kind of going, wow, this is an easy one. But I don't know where you live, but if you have sandy soil, you're very lucky, because in Sudbury it's mostly clay. And exception to the rule is out in Cartier, where we almost turn down beds because it's gravel. It's too fast, and it flows to the water table too fast. So I've had some challenges where we almost have to mix the soil to bring the percolation rate up to hold the water a little bit for treatment. As you can see, I'm just throwing things out, hopefully of interest. In clay, a 3-bedroom house, I need 42 by 100, 42 feet by 100 feet for the treatment, and nothing can be in that area. That means we have to gut the vegetation and the trees, model the clay, and then bring in the soil. Now, many years ago, we used to say that a building lot was okay to be 15,000 square feet. I almost need that just for the tile bed today. So the old lots are, now, if you have an existing lot and you have to put in a new bed today, there is a section in the building code that will allow you to put back as much as you can on your property. And that's the only discretionary part of the building code. In other words, they wouldn't hold you high and dry. Now, a holding tank is only good for when a defective bed is presented and there's no room for a new bed. They will allow a holding tank on an existing house. Otherwise, there's no such thing as applying for a holding tank on a new dwelling. And if you have property that there's no way you can put a sewage system in, and there are certain criteria. One is steep property, heavily laden rock, swamp or whatever, then the health unit would probably approve a holding tank. Now, the reason why holding tanks are not approved is because way back when they took a survey and a lot of people were basically pumping their holding tanks to the ditch to save money. And that's what happens because the holding tanks are very costly. The treatment units that everybody is always wondering, there's a wonder treatment unit that'll solve all our headaches. There's no such thing. The clay property that requires 42 by 100 for conventional, I can cut that area in half with the special treatment units. And there's the Waterloo biofilter, there's EcoFlow, what are the ones? microfast. I design any of these units, and there's also a couple other units that don't require electrical pumps. But the whole thing about the special treatment is just bombarding your sewage with oxygen. That oxygen creates the aerobic bacteria that become very aggressive, and they remove everything out of the sewage that causes biomass. So that's the reason your footprint is cut in half. So your 42 by 100 area can be cut in half with the special treatment units. These are biofilters in certain forms, and usually I tell everybody count on another 8 to 10,000 just for the biofilter. So you know, it's just going to be a little bit more money, but if you don't have room, it's quite worth it. And at the same time, it doesn't cause biomatting. And there are special further treatment you can put on these biofilters that can remove up to 60% of your phosphorus and nitrogen, which is the main culprit polluting lakes. And if I could share any good advice, if there's a sensitive lake, but I'm sure it can't be governed, but it would be nice if everybody was conscientious enough to put in the special treatment units. But when it comes to money, I'm finding that doesn't happen. Okay, so I'm going to wrap this up. I just tried to top it up because I know Brittany had every detail possible. Decided to give you a little bit of experience I've had. And I think, should we open up for questions now, or is it okay? Do we have a couple minutes for questions?
Take a couple questions.
Okay. Yes.
I heard Brittany say that if you wanted to have a holding tank, you had a contract with an operator.
Not just the contract, but you also need to meet the 4 requirements. So how Ed just talked about, if you have an existing system and there is no room for a new system,
Yeah.
then they would allow. So that's one of the 4 conditions. So on top of meeting that one of 4, you would also additionally have to have that agreement between the waste haulage mover.
Yes.
How difficult is it to put in these the filters in your existing?
I had no problem putting mine in. You know, the inlet and the outlet is just. Oh, the question was how easy is it to put in the effluent filter on your existing tank? Sorry. Yeah, well, on the outlet there's a T. You would remove the T, and it's just a plumbing fixture, and the filter would just join on the it could be a 3-inch or a 4-inch ABS pipe, and you just glue it on. Now, if that filter has any weight at all, there's usually a screw-on leg that goes down and touches the bottom of the tank. Otherwise, some of the filters are small enough you don't need that leg, so it's not that hard to do.
And I have another question too, if I may. Contaminating groundwater. How do you know? Like, 'cause that's all. You know, it's not like you've got seepage and drainage.
Your well would tell you. So if there's any well, okay. So sorry, can you just? So yeah, how did you word your question, just so I can repeat it?
I'm sorry.
How did you word your question, just so I can repeat it?
That's okay, I understand.
How can you tell if you're contaminating the groundwater?
So the question was, how can you tell if you're contaminating the groundwater? So one of the ways to do that would be if there's a well on the property or a well nearby, you can actually bring a sample in and have it tested. And if you're noticing any elevations in, I believe it's phosphates and nitrates, then you know that there's that possibility that there's a groundwater contamination.
But no well. There's no well.
Oh, there's no well.
Lakefront and you take the water to the lake.
Well, you know, I've been heavily involved. I was just in a lawsuit where it was a neighborhood fight, and they thought they were polluting the lake. The health unit is called in. Like if you have any concern about contamination or leaking sewage or something that could be, you know, polluting the groundwater table, there's a method. You call the health unit, you file a complaint. They have to send an inspector out to survey the situation, and if there's a pipe or anything's visible, they have ways and means. You can put dye, you can do a dye test, you can do things, and they would order the household to fix, and if it was directly discharged on the ground, they would have to stop, get the tank pumped, and treat the area. I don't know if that answers that correctly or not.
Well, I'm thinking as a lakefront liver, I worry that I can't see that. I mean, my
okay, so
working and everything's good, but I don't want to think that maybe there's something that's not good.
okay, you live on the lake and you're concerned about
I just don't want to be one of them.
no, and you know, in all fairness, there are beds that are only working partially, and they're old. We don't see it. Only by, inspection maybe, or something very visual is pretty obvious, right? But you have to remember, the beds that are old and are underwater have plumes. But nobody's going to be testing the groundwater table and everything. We just have to rely on good judgment, how you treat your, how you're treating your own system. Other than that, if you file a complaint, the health unit will take a sample for you. No, but just think about if your bed is 25 years old and it's not flushing very well, you need to replace it. And when you replace it, it'll come up to standards since '98.
Okay, we have another speaker, and so we're going to get Dr. Charles Ramtera up here, and then he's going to talk for about 10 minutes.
Richard?
Yes?
We're going to cancel Charles for today because we're over, so we decided to
Oh, okay. Change of plans. We'll carry on then with questions here. And then afterwards, we will have our door prizes, and again open up for the social. We'll just make a little plug. Also, the Greater Sudbury Watershed Alliance, we're also involved in other issues here with our lakes, milfoil, with the salt concentration in lakes. And also we do have more board members. I see Alex there at the back. We also have Susan and Sherry. And I'll just also put in a plug. We have 3 board members, Irene, Elaine, and one other who are at the choir tonight and also tomorrow night. So if you would like to enjoy that, please do so. So carry on with the questions here.
Ed, when you install the filter, do you have to go inside the tank, or can you do that from outside?
You would. There are two lids on the tank.
Yep.
Well, so I'd have to take it. Mine was a big, huge honking cement lid, about 150 pounds. And then when I took that off,
yep,
I put a riser on it. So if you don't have a riser, that's a good time to get your riser up to grass level. And once you open that hole, you'll see the baffle that's there. Yeah, it might be a little onerous trying to get in there a bit, but it'd be nice if you pumped your tank first, so you don't fall in there and have a good drink.
That's the only way to put it in.
Yeah.
I don't know if that answers your question or not.
What's the cost range now for the lower end to the higher end of putting in a septic system?
I can only share with you that the health unit's fee is $900, and over the years I've seen anything from $12,000 to $50,000. So that varies in regards to the conditions of the property.
Yeah.
But nobody's running their machinery for, I don't even know if they run it for less than 15 today. And that's just my own personal, if I was to tell my family member, it's going to be costly to put in a new bed. But here's the other thing, you can put in the bed yourself if you're handy and you have a friend with equipment. And I know there's contractors here that are going to shoot me after, but I mean, that is in the code. You are entitled to put your own tile bed in. Yes?
And how does the building code address backwash water from water softeners? What's the proper disposal methodology?
Well, that should be going not in the tank, so that could be going out into the environment, because that's not contaminated, but it's salt, right? Yeah, and we're worried about salt in our lake here with all the roads and everything. I'm kind of thinking you could make your own little pit in the ground somewhere, like anything else. Probably a lot of people are putting it back into their sewage systems.
Yeah, and I've seen a lot of field beds fail under that.
Yeah, exactly. And what's happening is you just can't put a lot of stuff in that septic tank. You have to, you can throw off the bacteria culture and have all kinds of. If you're smelling that good sour smell, you know the bacteria is working really well. That methane gas is good stuff for you. Front back.
You had a bionest put in 2014. I mean, you did the.
Bionest, yes, I designed it, yes.
Shortly after it's installed, we were contacted by a firm from Brantford.
Yes. Okay, that's very good. So the highly treatment units, the biofilters, just recently they had to go through more stringent requirements, and now it's a yearly inspection, and a lot of the units had to beef up their process so that they could actually gain access and easily take a water sample after it goes through the biofilter. So okay, so I don't know if you heard that. The health unit said there's no requirements for a year. I'm not sure if that was answered correctly, because all these special treatment units have to have their units inspected yearly, and that's just fairly recent. And the cost might be $300. I have people complaining, but that's not that expensive considering they'll inspect your unit, take a sample, make sure that your biofilter is providing the proper treatment to remove the biomat in your bed.
I've done 3 years now, and there's no problem. I wouldn't mind doing it at 5 years. It doesn't help you. It's nothing about.
Well, okay, what's happening with BioNest? I cannot design BioNest anymore because they haven't met the requirements out of Quebec like the other competitors have. I understand they're working on that now. It should be. You know, if you, I can help you with that. Corresponding with BioNest, I can help you with that. If I have a card, you want to give me a call, I'll certainly help you out on that. Well, the new requirements for BioNest will state that will be inspected yearly. Now, I don't know what they're doing going back on the older ones. That's an awfully good question, and yeah, you should be talking to the health unit. If you're having trouble there, the manager, Rick Ald, and we talk. I'll call him and see what's up. Yes.
The house I have is built in the early 1993, roughly there, and I was told that the system was put in with the mantle. So basically, my understanding is your drainage, your tile bed, the water runs directly through and ends at a drop-off point. It doesn't percolate throughout the field bed. Well, that was a requirement, I think, at the time.
I was heavily involved with pushing mantles back then, and they became totally mandatory in '98, but I was pushing them prior to that. So what it is in clay, the water will run, and you need 50 feet beyond your filter to hold that, and the clay will take some of it, you'll get transpiration, evaporation, and the rest of it will go in your clay as long as you have that huge mantle.
Do they have a shorter life expectancy than a regular system? Because I find the water hits that clay wall and backs up from it.
Okay, today you don't have any clay walls anymore. Totally raised. My designs show everything right out of the clay. And that's sometimes is onerous because it's so high. But
is there a way to repair that when you have to remove all that material at the end of the mantle and replace it with?
Well, you could chisel out clay and provide sand or raise your filter. You got to be high. Your filter should be high and dry. Okay, just think about it that way. And if water is being held by a barrier, your filter is too low, and I don't know if you can break that barrier out into and.
There'd be a street. There'd be a street.
Yeah. So yeah.
I'm just going to ignore it.
You are among a lot of people with similar situations, not just you. Yes. At the back?
Yeah. There's a second concern about changing the T to a filter, the outflow, where a proper respirator.
Yes.
Otherwise, it's going to be dead weight.
Yeah, that's a good point. You wear a proper respirator if you're fooling around with tanks, and because those are dead spaces. You know, there's very little oxygen, especially if you get in the area of the cavity. There's no oxygen that can take you out. So that's a very good point. Thank you.
So I did mention that, and one thing I want to add too is that your septic tank, it's actually considered a confined space. So if you're planning on doing anything like that, you want to make sure that any of those gases have been removed from the tank. You know, you don't want to be lifting your lid up and then jumping right in or something. You know what I mean? That's just not good. You will end up dead, just like this gentleman said.
Sometimes putting a filter in means that you're getting pretty close to.
Yeah, no, that's a really good. Thank you very much for that. That's a very good point. And I mean, I've taken all that dead space stuff in my education too, where there's no oxygen. So.
Just down in London or southern Ontario, there was 2 or 3 firemen that went in to rescue somebody. They all went.
They all went. That's typical. There's no oxygen in those dead spaces for sure.
Everyone over here.
Yes.
These Enviro filters, how often do they have to be completely replaced?
Oh, they should be good for they're all plastic. All you do is hose them off every year. I mean, the requirement is you screw your little filter and you hose it off in the first compartment. But I saw in a picture that they're hosing it off in the first compartment. But I mean, there's only so much you can do, right? Because the lids are 2 lids to take off might be onerous.
Right there. But so the picture that's it's being covered right now.
Sorry.
So you can actually see right there, he's hosing off his filter.
Yeah, so you're basically hosing off because the filter is going to be partially plugged. My filter wasn't plugged much, but I have a cottage and I'm not using it a lot, so it's a different story. So at the cottage, in regards to pumping, when I pump my tank, I asked the guy, you know, what is it like? He said, oh, it's really clean. So that kind of judges how often I have to pump my septic tank. You know, I mean, if it's a cottage, you might not have to pump it for 7 or 8 years. A busy household, 2 to 4 years. You got to take those solids out of there.
I have a question about, I have an existing field that I'm looking at replacing.
Yes.
Mainly because the cement tank is, I don't know how old it is, but it's pretty rotten. You know, the baffles have rotted off, and I did install a filter and things. But when I'm taking a soil sample for that field, which is an existing field which doesn't seem to be having any problems, how deep do I need to go? And do I do that away from where my lines are now?
So where you're taking your sample, so anytime you're bringing in a sample for percolation testing, you want to take that sample at approximately 3 to 5 feet below the ground, and you want to make sure that you're taking that sample exactly where your distribution pipes would be on average. And when you're taking that sample, you want to bring it in being representative. So if you're seeing a couple larger stones, I want those stones. I want to know exactly what is in your ground when you're bringing it in to be tested for that percolation rate. So you'd want to take it where your new distribution pipe would be, and 3 to 5 feet down. And I want those big stones, I want those chunks of clay, a silt, anything that's in there, you want to bring it to me so that I can give you the accurate result for the proper new system.
So when you say 3 to 5 feet, you know, where my distribution lines are now, you want samples from below where the distribution lines are going to be for what depth?
Well, that's your treatment area. So you want it down there where it's
yes, exactly.
Yeah.
But do I dig like a 2-foot depth and bring you that?
So what I do on a site, I want to know if there's good soil for 5 feet, because that's your base. 5 feet, if you have good soil, and say the water table or the rocks down that far, that's your requirement. So a 5-foot test hole is usually done in sand, right? Because it's good. So you got to know. So you dig your 5-foot test hole in sand. You see the soil. You look down; it's dry. There's no water table.
Yeah.
Now you know you can go directly in the sand. But I don't have that luxury. I start digging, it's clay, I quit. Because there's no use taking a soil sample of clay.
Yes, and my bed, it has been built up. I mean,
so that's important.
But probably 40 years ago. But you know, it's not. It was material brought in.
That's imported. I need to get native when I design. So I have to hunt around beyond the imported to see what the native is before I assess. And usually I go somewhere where there's no import, and I'll dig and see what it is. And often if it's 5 feet of sand, and usually it's pit run, old beds are pit run, they just place that on clay.
So, but if I'm replacing the field where it is, do I take that soil or do I take native soil?
It's got to be native for a design. Like the health unit won't. The health unit needs a native soil analysis.
Okay.
Okay.
Yeah.
Okay. We're running a little short of time here, so I'd like to call on Brittany now for our pick out our tickets for our door prizes. The first door prize will be for these 3 sweet gale plants. Or we'll do one at a time. Okay.
Yeah. So the first number is 9670998.
Okay.
Okay, so our second winner is number 9670959. Perfect. Congratulations.
Thank you very much.
Okay, so our third winner is number 9670907.
Oh, we have a winner.
Perfect. Congratulations.
Congratulations.
Thank you.
And for our next door prize, we have this beautiful Country and Cottage Water Systems book.
And the winner of the book is number 9670912. 912. No 912.
Okay, and then for the grand prize tonight, we have the Septic Social Gift Certificate, which is from one of our sewage contractors located within the greater Sudbury to redeem the amount on receipt up to a maximum value of $250. So this is a $250 grand prize. And the ticket is?
All right, the ticket number is 9670899.
Yes.
Have to come up. Come on now.
Congratulations.
Congratulations.
Do you want to invite people for drinks?
Yeah. Okay, I'd now like to call on Brittany. Would like to thank her very much. The envelope, please. And I'd like to call on Ed to also receive a little token. And thank you very much. And so now, please come on over here, and it's now time for the social. And over on this side again are our contractors who you can talk to, and you can come up and talk to Brittany and Ed for any further questions. Thank you very much for coming here tonight. Thank you.
Yeah, so, you know, I